Our heavens are alive with the light of other worlds, stars of red, yellow, white, and blue. All have their own life cycles. They grow, they live, and they die, often in grand explosions. Our nearest star, we call it the Sun, blinds us to all others. But when the Earth has turned away, we see the other stars. If we live in a city, we only see a few. Away from the city lights, we can see millions. And if we use a telescope, we can see billions. The distances in space are huge. If the Sun is the same size as a large beach ball, the Earth would be 60 meters away, only as big as a pea. Jupiter would be 300 meters away and as big as an orange. Pluto would be 2.5 kilometers away and about the size of a sesame seed. Distances in space are so vast, we use light to describe it. Light is fast, 300,000 kilometers a second. That's 7 times around the Earth. From the Sun, it takes 8 minutes to reach Earth, half an hour to Mars, and 3/4 of an hour to Jupiter. It would take 4 years to reach our nearest neighbor, the star Alpha Centaurus. A light year is the distance light can travel in a year. Our Sun is one of the stars in the Milky Way. The Milky Way is a huge collection of 200 billion stars called a galaxy. It's a spiral galaxy. Nearby, 1/2 light years away, are 2 smaller galaxies known as the Magellanic Clouds. The Milky Way, along with 30 nearby galaxies, make up what is known as the local group. And this is in turn a part of a group of thousands of galaxies called the supercluster. There are different types of galaxies. Andromeda, a spiral galaxy like the Milky Way, is a member of the local group. Some galaxies are called barred spirals, and others are classed as elliptical. As well as galaxies, there are smaller groups of stars called globular clusters. They contain mostly old red stars packed very closely together. At 620 light-years across, Omega Centauri is the largest known globular cluster. They are found outside galaxies, sometimes forming a dotted halo around them. The Milky Way, too, has globular clusters surrounding it. They are the reddish clusters. In the spiral arms of a galaxy, there are different types of clusters called open clusters. These contain anywhere from a few to hundreds of thousands of stars, all of different ages. All galaxies are traveling away from each other. The further away they are, the faster they are traveling. If we trace back along their paths, we find that they all originated from the same place 15 billion years ago. The best explanation for this is that there was a giant explosion. Scientists call this the Big Bang. 15 billion years ago, everything in the universe was compressed into a tiny point, smaller than an atom. Then came the Big Bang. This produced vast quantities of hydrogen, plus some helium and a little lithium. So how did hydrogen produce the universe as we know it? The spiral arms of galaxies grow by collecting gas from space. Then, within the galaxy, the gas's own gravity draws the gas together into clouds. These clouds become vast stellar nurseries where stars are born. The birth of a star begins with gas falling into the center of a cloud, forming a protostar. It is not yet hot. Like water draining from a bath, the gas begins to spin, forming a rotating disk. Planets are formed in the disk while the protostar in the center collects more and more hydrogen. Compression causes the gases in the protostar to heat up. When it reaches 5 to 10 million degrees, hydrogen atoms are squeezed together to start an atomic fusion reaction. This is the first of many steps in forming the different elements of the universe. The heat drives away a lot of the gas as stellar wind. Stellar means star, so it is a wind from the star. In images from the Hubble Space Telescope, we can see many young stars with their stellar winds. This is a cluster of hot blue stars. The atomic reaction happens only in the core where the pressure is great enough. The heat and light and radiation bounces around inside the star so much that it takes over 100,000 years to reach the surface. The heat produced causes turbulence in the sun's photosphere. The energy then leaves the star in the form of heat, light, and ultraviolet. The outer planets in our solar system are made of gas the same as stars, but they don't become stars because they are not big enough to squeeze hydrogen together to start the fusion reaction. Jupiter would need to be larger if it was to become a star. The smallest star is a red dwarf, which only just becomes red hot. The temperature of a star depends on its size. We say our sun is one solar mass, and its fusion reaction heats the surface to yellow hot. Red dwarf stars only become red hot. Bigger stars become white hot. Blue stars are huge, burning up their fuel at a furious rate. They are blue hot, which is hotter than white hot, so the bigger the star, the hotter and the brighter it is. These blue stars in a cluster called the Pleiades are 20,000 times brighter than the sun. The size of a star also determines its fate.